This part, this is a PEEK plastic part at its current design iteration. This part is part of a bearing assembly for an electric motor diagnostic test stand. And this part, which we continue to produce today, actually came to us as a result of a reshoring effort during the coming out of COVID due to supply chain disruptions. Again, this component is part of a larger assembly that we integrate to a certain point. The final integration into test stands is done at the customer site. So we built these up to a assembly level with probably 7 or 8 other components that we build to go into it. And when this part first came to us, it was sort of a legacy part for the customer produced in a different material, and it was run in a diagnostic facility overseas in relatively large volumes. There were some product iterations on the customer side, and they started seeing failures in these components that necessitated a design cycle and ultimately necessitated a material change. And the customer, with their existing supply chain relationships, was having a difficult time making that happen coming out of COVID. So we got involved in the project at that point. So probably between 4 and 5 years ago now. And we've continued to support the customer since then. 2 main problems, I think. The reshoring was just sort of necessitated by disruptions coming out of COVID. Then a design change in the hardware that was ultimately being tested on these diagnostic test stands in a factory. So it's for 100% inspection of the product coming off a line. There were design changes to the product that were starting to cause failures in this particular component in the assembly. In the simplest sense, was a thermal related failure where there was more heat being generated in an area of the assembly where it wasn't previously. So we worked with the internal engineering staff at our customer, and there were kind of 2 main approaches to 2 components of the solution to the problem. One was a material change from another plastic resin to now this is produced in PEEK. The other was some geometric changes for airflow and cooling and relatively small, subtle details in the assembly that we were able to work with customers' engineers to understand, what the requirements were that would not compromise the integrity of their test or cause any other problems in the products coming off the line. And so the customer ultimately was responsible for the geometric changes to the part design, but we were involved in that process, and we were able to provide DFM-related feedback to ensure that the changes that they were proposing to make would be a cost-effective solution. There's nothing from the outside that's terribly complex with this part. It is just a small, for us, a 5-axis part. There are, again, in this particular part, just a couple very tight tolerances for bearing fits and other things. The main challenge with this particular part was the stress relieving of the PEEK material during machining. And so it required a different approach, I guess, than just the direct kind of all the features that you see at one time to kind of allow the material to stress relieve and to end up where I wanted to be. And then there are mating parts, of course, with bearings and shafts and things that go in here. While there is a little bit of complexity to the nuance of the part, I think really the main value that we were able to add in the case of this part is really at the assembly level, and having control of all the components that go into that subassembly, and then ultimately being responsible for the functionality of that subassembly. And so the customer is not buying tolerances on 8 different drawings and then dealing with whatever happens at integration and fit up. We're building all those parts and we're putting them together, and then we're meeting a specification at the assembly level, which then goes directly to the functionality of that subassembly. So with this project, the real high-level benefit to the customer is a single source for an integrated subassembly. And then rewinding back several years, it really got them out of the COVID supply chain jam where real time they were having failures on a manufacturing line overseas, and there was seemingly no quick solution to solve that problem. So we were able to very quickly iterate with them, and we had completed assemblies together and out the door, shipping overseas within days of being engaged on the project.